Hey everyone, and welcome back. As engineers involved in injection molding, we all care about quality right now. And one of the things I've always kind of wondered about is that contact pressure between mold halves. How do you really make sure that's spot on? So today we're going to do a deep dive into a presentation about troubleshooting uneven clamping in injection molding.
Yeah, clamping, it's kind of like the unsung hero of quality, isn't it?
I hear that a lot, but I'm not always sure I fully get why. Can you kind of break that down for me?
Well, you got to think about it. Consistent clamp pressure, that's the foundation for like everything. I mean, it makes sure your parts are the right shape, the right size, and it even impacts your cycle time so you can make more parts faster without sacrificing quality.
Okay, so well-maintained clamping mechanisms and plightens are really key for that then.
Oh, like,
That's what I'm getting from this presentation.
yeah, absolutely. But it's not just about the equipment itself. Even if you have top-notch machines, misalignment can throw a wrench in everything.
Misalignment. So you're talking about more than just the mold halves themselves.
Right. We're talking mold halves for sure, but
Hmm.
also platens and the whole clamping system. They all got to work together perfectly. If anything's off, you end up with uneven pressure across the mold, and then boom, you got inconsistent parts.
So how do you catch those alignment issues before they become a problem? Is it like super precise measurements and
Well,
stuff?
actually, the presentation has a couple of simple checks you can do, like just grab a machinist level, make sure the machine itself is level.
Huh. I never thought about the machine itself maybe being off level.
It happens, and it's an easy fix. While you're at it, measure the distances between your tie bars, too. If those aren't consistent, you might have some deeper alignment issues that'll show up in your parts eventually.
Good tips. Now, the presentation also talks about flash, which I'm sure we've all dealt with at some point.
Yeah.
They're saying it's usually caused by alignment problems.
Yeah, especially with thin-walled parts or if you're running things fast. If your clamping force isn't strong enough to hold those mold halves shut when you inject plastic, it'll find a way out and you get flash.
So it's all about making sure there's enough pressure to create a good seal. But how do you actually diagnose that? Just looking at the part, or is there a more scientific way?
Well, eyeballing it is a good first step, but to get more precise, the presentation talks about this neat trick with pressure-sensitive paper. Ever use that?
I've heard of it, but never actually tried it.
No.
So how does that work? Just stick a piece of paper in the mold and hope for the best?
Not quite. It's a special kind of paper you put along the parting line of the mold. Then when you clamp it, the paper changes color based on how much pressure it's feeling.
So it's like a color-coded pressure map of your whole mold.
Exactly. You can see where the pressure is nice and even and where there might be high or low spots.
Wow, that's pretty cool. But it's not just about seeing the pressure right. You can actually use that information to pinpoint problems.
You got it. Powerful stuff. But we're getting ahead of ourselves. Before we dive too deep into that, let's look at some other clamping and tie bar challenges the presentation highlights.
Okay, sounds good. What else should we be watching out for?
One thing that's easy to miss is buildup on the parting line. If your clamp isn't locking right or the pressure's off check, if you need to clean things up, you don't want anything messing with that contact point.
Right. And even if the parting line's clean, this presentation makes it clear that temperature changes can cause problems too.
Yeah, as the mold heats up during the cycle, those platens can actually expand, and that changes the clamping force.
So you can't just set the clamp pressure and forget about it. You got to think about those temperature shifts and how they affect the platens. So cooling systems are super important then,
Exactly. Got to keep those platens cool and stable for consistent performance.
which all goes back to making good parts quickly right. If your platens are warping, you'll need to slow down or risk bad parts.
It's all connected. Now let's talk clamp force specifically. The presentation spends a good chunk of time on getting that just right for each job.
Okay, so how do you figure out how much force you need for each mold and material?
There's no one-size-fits-all answer, unfortunately. It depends, but the presentation has some good guidelines. Like, they recommend using the smallest machine that can do the job properly.
I'm guessing that's to avoid too much clamping force, which could cause flash or even damage the mold?
Exactly. It's about finding the sweet spot. Enough force to keep things closed, but not so much that you cause problems.
Makes sense. Any other tips for fine-tuning the force?
Yeah, they really stress watching the plastic flow during injection. Pay close attention to how it fills the mold. Look for signs of overpacking or short shots. That tells you if you need to adjust your clamping force.
Sounds like it takes a lot of observation and adjustment.
Yeah, it's a bit of a balancing act. Now, before we move on, I want to mention a couple of platen problems that can really mess with your clamping uniformity. Wrapping and bowing.
I've heard those terms before, but honestly, I'm not sure I totally get the difference. Can you explain that?
Sure. Wrapping is when the plate in itself starts to kind of deform under all that pressure, like it's stretching or bending around the mold. That leads to uneven pressure and inconsistent parts.
Okay, I can picture that. So how do you prevent that?
The presentation has a few ideas. One is making sure your mold takes up at least 70% of the space between the tie bars. That helps spread the clamping force out more evenly.
So a good, solid foundation is key. And what about bowing?
Bowing is when the platen kind of bends in the middle like a diving board, also causes uneven pressure.
Ah, okay, I see the difference now. So how do you stop that?
Cooling is really important, just like with warping. Keeping those platens at a stable temperature helps a lot. They also mention pre-stressing the mold, which can help distribute the pressure more evenly.
So pre-stressing is like giving the plate a little extra support.
Yeah. And they also mention using something called negative pressure TCUs. They can help avoid coolant problems that contribute to bowing.
Negative pressure, what now?
TCUs. It stands for temperature control units. Think of it like a fancy system that circulates coolant through the mold and platens. It helps keep the coolant flowing evenly and prevent air pockets, which can cause temperature variations in bowing.
Okay, so it's not just about cooling. It's about making sure that cooling is really precise and consistent.
Yeah. We've talked about a lot here, from alignment to pressure dynamics to keeping those platens happy.
It's amazing how much goes into making good injection molded parts. But I feel like we're just getting started.
You're right. There's a lot more to explore, and we'll do just that in the next part of our deep dive. So, all this talk about clamp pressure and how important it is has got me thinking. We've talked about measuring tie bars and watching the plastic flow and even using that pressure-sensitive paper. But are we really getting the full picture with all that?
That's a good question. What are we missing?
Well, all those methods are important, but they're kind of like looking at the problem from a distance. What we really need to see is what's happening right at the surface where the mold halves meet. That's where the magic happens.
Yeah, it's that interface that determines the quality of the final part.
Exactly. And the good news is there are tools out there that can give us a close-up view of that contact pressure. Imagine being able to actually see how the pressure is distributed across that whole surface.
Well, that would be amazing. But how do you measure something like that? Some kind of Newper sensor or something?
There are different technologies, but one that comes to mind is pressure indicating sensor film.
Wait a minute, isn't that what our sponsor, Sensor Products, Inc. specializes in?
You got it. They're a leader in this field, and their sensor film is a game changer for anyone who's serious about injection molding quality.
Okay, now I'm really intrigued. How does this sensor film work?
It's pretty cool, actually. You basically put this thin, flexible film between your mold halves. Then when you apply clamping pressure, the film changes color based on how much pressure it's sensing.
So you can literally see a map of the pressure points.
Yeah. It's like magic, but it's actually science. The film has these tiny microcapsules that release a colored dye when you squeeze them. The harder you squeeze, the more dye comes out and the darker the color.
So it's like X-ray vision for your mold. You can see high pressure, low pressure, and any inconsistencies across the whole surface.
Exactly. And this isn't just about pretty pictures. Think about troubleshooting flash, for example. Now you can see exactly where the pressure is weak and fix it.
And wouldn't this be great for optimizing alignment, too? You could adjust your mold halves until you get that perfect, even pressure distribution.
Absolutely. It's like having a cheat code for perfect clamping. And it's not just for troubleshooting either. Think about process optimization. You can experiment with different pressures, different materials, and see how they affect the pressure in real time.
It takes all the guesswork out and replaces it with hard data. You can make smart decisions based on what you're actually seeing, not just what you think is happening.
It's a whole new way of thinking about injection molding, and it all starts with understanding pressure.
This whole conversation has really driven home the point that pressure is like the unsung hero of injection molding. It's the force that shapes everything.
It's the invisible hand that guides the process. And with tools like pressure indicating sensor film, we can finally see that hand at work and use it to our advantage.
This has been a real eye-opener. I feel like I have a whole new understanding of clamping and how pressure affects part quality.
Glad to hear it. It's always fun to explore these topics and see the light bulbs go on.
Speaking of light bulbs, there's one more thing about pressure indicating sensor film that I think you'll find really interesting.
Let's save that for the final part of our deep dive.
All right, spill beans. What else can this pressure indicating sensor film do?
Well, we've talked about how it shows you the pressure distribution and helps with stuff like flash and alignment, but it can also help you design better molds.
Really? I wouldn't thought of using pressure sensing for mold design.
Think about it. Each mold is different, right? Different shapes, different features, and they all have their own little stress points. Using the sensor film during testing can show you exactly how your design is affecting the pressure.
Oh, I see. So you can see if there are spots where the pressure is too high, which could wear out the mold faster,
Mm-hmm.
or spots where it's too low, which could cause problems with filling or part defects.
Exactly. You can catch those problems early on before you even make the mold.
That's amazing. It's like
Yeah.
you can predict how the mold's going to behave under pressure.
Yep. Data-driven design. And the film makes that data easy to understand.
You know, this whole deep dive has really shown me how important pressure is in every part of injection molding.
Couldn't agree more. It's the key to making good parts.
I feel like I've learned so much about clamping and pressure and how they affect quality.
It's been great exploring this with you.
And for our listeners who want to learn more about pressure indicating sensor film and how it can help them make better parts, I highly recommend checking out Sensor Products Inc. Their website has tons of info case studies and videos about this technology.
They're the experts in pressure sensing.
Well, that wraps it up for this deep dive. Big thanks to our expert for all the insights and to Sensor Products Inc. for sponsoring this episode.
See you next time.
And to all our listeners, keep learning, keep innovating, and keep pushing the boundaries of injection molding.